bodies connected by a string which passes over a pulley. One body is suspended and other body is placed on an inclined plane. Now in the diagram we have an inclined plane AB. AB is the inclined plane and BC is the vertical plane. And a pulley is set at the highest point of the inclined plane. A body of mass m1 is suspended by using a string. This is the body of mass m1 which is suspended by using a string, and that string passes over that pulley. m1g is the weight of this body and T is the tension acting in the string in connection with the motion of the body of mass m1. Another body of mass m2 is placed on the inclined plane. Another body of mass m2 is placed on the inclined plane. This is the body of mass m2 which is placed on the inclined plane, and the weight of this body, that is m2g, is acting vertically downwards. Now we can draw a parallelogram or rectangle to resolve the weight of the body of mass m2. So this is the rectangle or parallelogram. Weight of this body which is placed on the inclined plane is m2g, which is acting vertically downwards, and rectangular components of this weight m2g are m2g cos theta, m2g cos theta which is perpendicular to the inclined plane AB, m2g cos theta which is perpendicular to the plane AB, and m2g sin theta is another rectangular component of m2g, and m2g sin theta acts parallel to the inclined plane AB. T is the tension acting in the string in connection with the motion of the body of mass m2, and this is the pulley. Here we can assume this pulley as light and frictionless pulley. Now, if m1 g is greater than m2g sin theta, m2g sin theta, then the body of mass m1 will be moving downwards with an acceleration a, and the other body of mass m2 which is placed on the inclined plane will be moving with the same acceleration a up the inclined plane towards the pulley. Let the weight m2g of the body placed on the inclined plane AB, weight m2g of the body placed on the inclined plane, AB, placed on the inclined plane AB, be resolved into two rectangular components. The weight m2g of the body placed on the inclined plane AB be resolved into two rectangular components. Two rectangular components. Two rectangular components, m2g cos theta and m2g sin theta, m2g cos theta and m2g sin theta. such that m2g cos theta component is perpendicular to the inclined plane AB. m2g cos theta is perpendicular to the inclined plane AB. Is perpendicular to the inclined plane AB. m2g sin theta is parallel to the inclined plane AB. Here m2g cos theta component is perpendicular to the inclined plane AB and m2g sin theta component is parallel to the inclined plane AB. And also m2g sin theta is acting down the inclined plane AB. m2g is the weight of the body of mass m2 which is placed on the inclined plane. m2g cos theta component is perpendicular to the inclined plane AB and other component is perpendicular to the inclined plane AB and other component m2g sin theta is acting down the inclined plane, or m2g sin theta is parallel to the inclined plane AB. If m1g is greater than m2g sin theta, if m1g is greater than m2g sin theta, the body of mass m1 which was suspended, the body of mass m1 will move downwards with an acceleration a, will be moving downwards, with an acceleration a, and the other body of mass m2 which was placed on the inclined plane AB, the other body of mass m2 will be moving up the inclined plane AB with the same acceleration, will be moving up the inclined plane AB with the same acceleration up the inclined plane AB with the same acceleration, considering the downward motion. In this case, in the diagram, the body of mass m1, for the body of mass m1, m1g is a weight which is acting downwards, and m2g sin theta is the rectangular component of m2g, so which is acting down the inclined plane. If as m1g is greater than m2g sin theta, m1 will be moving down the inclined plane and m2 will be moving with the same acceleration up the inclined plane. If m1g is greater than m2g sin theta, if the weight of the body of mass m1, that is m1g, is greater than the rectangular component m2g sin theta of the body of mass m2, then m1 will move downwards and m2 will be moving up the inclined plane. m2 moves up the inclined plane AB with the same acceleration. So this is the condition, that which body will be moving downwards and which body will be moving upwards. Now considering the downward motion of the body of mass m1, considering the downward motion of the body of mass m1, downward motion of the body of mass m1, which was suspended by using the string, and string passes over the pulley. Considering the downward motion of the body of mass m1, net downward force acting on the body of mass m1 is m1a, which will be equal to m1g minus t, which will be equal to m1g minus t, or comma t equal m1g minus m1a, same as the apparent weight of a body in a lift moving downwards with an acceleration a. In this case, apparent weight r can be compared with the tension T. T equal m1g minus m1a, equation 1, and this is the tension acting in the string in connection with the motion of the body of mass m1. This is the tension acting in the string. For the body of mass m1, m1g is the weight which is acting downwards, and T is the tension acting in the string. Hence, net downward force acting on this body of mass m1 will be m1a, and which will be again equal to m1g minus T. Now we can consider the motion of the body of mass m2 up the inclined plane AB. Similarly, considering the motion of the other body of mass m2 which was placed on the inclined plane AB up the inclined plane. Considering the motion of another body of mass m2, another body of mass m2 up the inclined plane AB, up the inclined plane AB. We get net force acting up the inclined plane is m2 dot a, mass into acceleration, which will be equal to t minus m2g sin theta. The body of mass m2 will be moving up the inclined plane under the action of two forces t and m2g sin theta. For the body of mass m2 placed on the inclined plane, m2 is the mass of this another body, t is the tension acting in the string in connection with the body of mass m2, and m2g sin theta is acting down the inclined plane. The body is moving with an acceleration a up the inclined plane, m2g sin theta. So net force acting on the body of mass m2 up the inclined plane is m2a, which will be again equal to t minus m2g sin theta. We get m2a equal to t minus m2g sin theta. Therefore, t equal m2g sin theta plus m2a. That will be equation 2. And that is also the tension, same amount of tension acting in the string in connection with the motion of the body of mass m2 placed on the inclined plane. T equal m2g sin theta plus m2a. That is equation 2. Equation 2. Comparing equation 1 and 2, we get same concept. Consider the motion of two bodies, find the expression of tensions, and then compare the equation of tensions. Comparing the equations of equations 1 and 2, we get m1g minus m1a, m1g minus m1a equal m2g sin theta minus m2a plus m2a, or comma m1a plus m2a, m1a plus m2a equal m1g minus m2g sin theta. Therefore, A is the common acceleration of the two bodies. A equal, in the denominator we have m1 plus m2, and in the numerator we have m1 minus m2 sin theta, bracket closed, and g is taken common. m1 minus m2 sin theta divided by m1 plus m2 into g. Small g is the acceleration due to gravity. This is the expression of common acceleration of two bodies such that one body of mass m1 is suspended by using the string, and the string is passing over a light and frictionless pulley, and the other body is tied to other end of the string and that body is placed on the inclined plane. This is what common acceleration of the two bodies in connection with this problem. So that is equation 3. Now from equation 2, using equation 3 in equation 2, we get the expression of tension T. Using equation 3 in equation 2, in equation 1 actually, not 2. Equation 1 was T equal m1g minus m1a equal m1 is taken common under bracket g minus a. Now putting the expression of acceleration a from equation 3, m1 bracket g minus under bracket m1 minus m2 plus m1 minus m2 sine theta whole divided by m1 plus m2 bracket closed into g. m1 minus m2 sine theta divided by m1 plus m2 bracket closed into g, small g. That is the acceleration due to gravity, small g. Now g can be taken common. m1 bracket opened, and also we can do the LCM m1 plus m2 minus m1 plus m2 sine theta whole divided by m1 plus m2 bracket closed into g, small g. Therefore, finally we get the expression of common acceleration a. Get the expression of tension, not the common acceleration. T equal m1 m2 under bracket 1 plus sine theta whole divided by m1 plus m2. m1 plus m2 bracket closed into small g. Small g is the acceleration due to gravity. So this is the expression of tension acting in the string in connection with both the bodies m1 and m2. T equal m1 m2 divided into 1 plus sine theta whole divided by m1 plus m2 into g. That is the tension acting in the string in connection with the body of mass m1 and also in connection with the motion of the body of mass m2 which was placed on the inclined plane AB. Now we can compare this problem with the motion of lift, with the upward motion of lift and downward motion of lift. So this is a diagram of lift and a man is standing inside the lift. And lift is moving downwards, upwards. And in the second case, again, same lift is drawn. Man will be standing in the lift, inside the lift. This is a man is standing inside the lift. Mg is the actual weight of the man. Mg is the actual weight of the man. Or m1g in this case, say this is m1g. Mass of the man is m1 and r is a normal reaction or apparent weight of the man during downward motion of the lift with an acceleration a. And for the first case, the lift is moving upwards with the acceleration a and the man is standing in the lift. Apparent weight of the man is m2g. Normal reaction is capital R. And right hand side we can draw the diagram in which two bodies are tied to the ends of a string and string is passing over a pulley. So for upward motion of the lift, apparent weight R is m2g plus m2a. During upward motion, weight of the man increases. During downward motion, apparent weight R is what? m2g minus m2a. m1g minus m1a. m1g minus m1a. And for the upward motion, it was m2g plus m2a. And if we compare this with this case where a pulley is set at the edge of the inclined plane at the highest point of the inclined plane, and M1 is suspended. M1G is acting downwards. T is the tension which is acting upwards. M1 is moving downwards with an acceleration A. Another body is of mass M2. Another body of mass M2 is placed on the inclined plane, and that is also tied to one end of the string. And M2G sin theta is the rectangular component of the weight of the body of mass M2, and T is the tension acting up the inclined plane. Theta is the angle of inclination. The body of mass M2 is moving up the inclined plane with the same acceleration A. Now, for the downward, M1 is moving with acceleration A, and tension acting in the string in connection with the downward motion of this body of mass M1 is M1G minus M1A. So that is same as the apparent weight of a man inside the lift moving downwards. And for the body of mass M2, tension T is what? M2G sin theta plus M2A. M2G sin theta plus M2A. That is the tension acting in the string, and that can be compared with the apparent weight of the man standing in the lift downwards, standing in the lift and which is moving upwards. This component is M2G sin theta. This component is M2G sin theta. And this tension acting in the string T can be compared with the apparent weight of a man in the lift, which is moving upwards with an acceleration. R equal M2G plus MA, and here T is equal M2G sin theta plus M2A. And also this problem can be this case can be compared with the general case where two bodies are tied to two ends of the string is passing over a pulley, and if M1 is greater than M2, if M1 is greater than M2, then the heavy body of mass M1 will be moving downwards with an acceleration A. Lighter body of mass M2 will be moving up with an acceleration A upwards. And if we compare this with this inclined plane problem, this is the inclined plane and vertical plane, horizontal plane, angle of inclination is theta. A pulley is set at the highest point of the inclined plane. A body of mass M1 is suspended by using string, and the string is passing over a pulley. M1G is acting downwards. M1G is the weight of the body of mass M1, and T is the tension acting in the string. Another block or another body of mass M2 is placed on the inclined plane. T is the tension acting on in the string in connection with the motion of the body of mass M2. Rectangular component of weight of M2G down the inclined plane is M2G sin theta. If M1 greater than M2 sin theta, in that case, M1 will be moving downwards with an acceleration A, and the body of mass M2 will be moving up the inclined plane with the same acceleration A. Now, on the left hand side, the formula of common acceleration of two bodies is what? M1 minus M2 divided by M1 plus M2 bracket closed into G, small g. That is the common acceleration of the two bodies. In the general case where two bodies are tied to two ends of the string, and the string is passing over the pulley. And again, common acceleration A is what? M1 minus M2 sin theta whole divided by M1 plus M2 bracket closed into G. On the right hand side. On the left hand side, M1 minus M2 means what? Mass of body moving downwards. Here, what is the expression of tension? 2 M1 M2 divided by M1 plus M2, twice of mass, twice the product of their masses divided by sum of their masses into G. Right hand side, the formula of tension is what? 1 plus sin theta. 1 plus sin theta bracket closed into M1 M2 into G divided by M1 plus M2. M1 plus M2 into G. Here for the left hand side case, acceleration for m1 t equal to m1 g minus m1 a, that is same as the downward motion of lift, tension acting in the string in connection with the motion of the body of mass m1. Expression of tension is what? m1 g minus m1, and for the body of mass m2 which is moving upwards, tension T is equal to m2g plus m2a, which can be compared with, again, for the right hand side for this case m1 T is equal to same as the left hand side m1 g minus m1a, and for the motion of the body of mass m2 which is moving up the inclined plane, m1 is moving downwards and m2 is moving up the inclined plane, and tension will be m2g sine theta plus m2a, m2g sine theta plus m2a. Just if theta is equal to 90 degree, then we get the left hand side case where m2g t is equal to m2g plus m2a, m2g plus m2a, and here t is equal to m2g sine theta plus m2a.